Hello students of the 12th class chemistry. This is your video number 14 and your chapter 1 solution, and we are tending towards the end of this chapter. In this 10th heading I am going to start the new and simpler heading, that is solubility. What is solubility? Suppose you have a water in a container like 2 liter of S2. Okay. Since solubility depends on temperature, suppose the temperature of the container is 25 degree Celsius. So it is 25 degrees Celsius, and the maximum NaCl dissolve or glucose dissolve is, suppose for example, it is not the practical value, 30 gram. Okay. Then its solubility would be 30 gram upon 2, that is 15 gram per liter. So this is the solubility. Means above 30 gram, even a small amount of solute can't be dissolved. This is the meaning of solubility. So I am going to read it for you one more time. Solubility of a substance is its maximum amount that can be dissolved, as I told you earlier, 30 gram in our example, in a specified amount of solvent. Since we took water, so it was fixed, so that's why it is we called as specified amount of a solvent at a particular temperature. Okay students, so this is your definition of solubility. So there are different types of solubility. First I will take a solid like NaCl, like glucose, dissolve in liquid. In B I will dissolve gas instead of solid. So first focus on case A, where I am taking solubility of a solid. Okay students, so I am going to explain you one more time. Solubility of a solid in a liquid. When a solid, come to the next page. Yes. Solubility of a solid in liquid. When a solid solute is added to the solvent, some solute dissolves and its concentration increases in solution. This process is known as dissolution. For example, I am going to explain by the diagram. Suppose there is a water free from any solute, and starting I am adding 1 gram of NaCl. So this NaCl will go and will dissolve. So this dissolve part or process is known as dissolution. Okay. So come to the student. When a solid solute is added to the solvent, some solute dissolves and its concentration increases in solution. This process is known as dissolution. While some solute particle, come to the next page, solution collide and get separated out of the solution. This process is known as crystallization. So there are two opposite processes which going on, and I'm going to explain with the example one more time. There's 2 liter of H2O. Initially I started 1 gram NaCl, then 2 gram, then 3 gram. So first the dissolution process will occur, and after some time some solid solute will out. Okay, there's less spacing available, so this would be crystallization process. Dissolution is the going in solution. Okay, I'm explaining one more time. What is dissolution? It is the pure solvent. If the solid dissolves like NaCl, it is dissolution. Okay, when it comes out, it is crystallization. So you know from the knowledge of 11th class chemical equilibrium, a kind of equilibrium is reached between two opposite processes, dissolution and crystallization. So there is an equilibrium, student, between dissolution and crystallization. Okay. So I am going to read it one more time for you. Solution collide and get separated out of solution. This process is known as crystallization. Full stop. A state of dynamic equilibrium, as I told you earlier, is reached. What is the equilibrium? Solute plus solvent is in equilibrium with solution. What is written here, student? I am going to tell you. This is your solution. This is your solution. So you can say solution is the equilibrium of solute plus solvent and solution. Okay. And you know, if the equilibrium will come, then Le-Chatelier's principle will come out of the chemical equilibrium chapter. I explained you in the 11th class. Okay, so I am coming to the next page here. Further, such a solution in which no more solute can be dissolved at the same temperature and pressure is called saturated solution. As I told you, if in 2 liter at 25 degrees Celsius of water you added 30 gram, means a 30 gram equilibrium is reached, means crystallization and dissolutions both are in equilibrium. So this solution condition is known as saturated solution. I am going to read it one more time, student. Yes. Such a solution in which no more solute can be dissolved at the same temperature and pressure is called saturated solution. And और उसके बाद unsaturated पे आते हैं. Then I am going to come the next page. Yes, and read one more time, student, what I am telling you. An unsaturated solution is one in which more solute can be dissolved at the same temperature. So this is the some different kind of explanation of how a solid solute dissolve in solvent like water and forms a solution. Okay. Further, I am going to explain you what is the effect of temperature and what is the effect of pressure. First, I am going to tell you what is Le Chatelier's principle. Okay, I am going to read it only because it was present in 11th class. So you can search the notes of 11th class and you can find the definition and explanation of this. I will use it here. Okay. Le Chatelier's principle in 11th class says that if at equilibrium, okay, this principle can be applied, student, only at equilibrium. If at equilibrium we change anything like concentration, temperature, pressure, etc., then equilibrium shifts in that direction where it can nullify the added effect. Okay, student. So if you are changing anything, it is going to nullify it. Suppose equilibrium is from A to B. Okay, I am increasing A. Automatically A will change into B to nullify the added A. Suppose I am going to add B, it will go backward to nullify the added B. So this is the simple way we can understand the Le Chatelier's principle. Okay, students. So I am going to explain what is the effect of temperature. So this is the effect of temperature. Since we know that dynamic equilibrium is, what is dynamic equilibrium? Come to the next page. I explained you earlier. Solute plus solvent makes solution. So effect of temperature is affected by Le Chatelier's principle in general if del S solution. Del S solution is the enthalpy of solution is endothermic. These things you know from your chapter of chemistry first book 11th class chemical thermodynamics. If student, if delta S solution is endothermic, that is endothermic means delta S solution is greater than 0, then solubility should increases and with rise in temperature. If you are increasing temperature, solubility will increase. If you decreases temperature, solubility will decrease. So this is the effect of temperature. I explained you by the use of the two things, this chemical equilibrium and student Le Chatelier's principle. Now come to the next page. Yes, in the next page, student, what I am going to explain, what is the effect of pressure. I told you we are studying the solubility of solid in liquid, okay, as well as the effect of temperature on solubility of solid in liquid. I explained you earlier in this video, and now I am going to explain the effect of pressure on the solubility of solid in liquid. Okay, in the next video we will discuss the solubility of gas in liquid, and I will study the Henry law as well as. Okay, so let's concentrate on the effect of pressure. Pressure does not have any significant effect on solubility of solids in liquid. Look, student, if you are changing the pressure and solid is dissolved in liquid, its solubility will not change. Why? It is so because solids and liquids are highly incompressible. I am going to explain with the help of figure, student. Suppose NaCl is dissolving, okay, and its solubility is, as we discussed earlier, 50 gram per liter at 25 degrees Celsius. So what is the effect of atmospheric pressure? No, because liquid is not compressible, its volume will not change, and solids are also not compressible. Both are incompressible. That can't be compressed. So no effect of solubility of pressure when we are discussing solids solubility in liquid. So students, I am going to tell you about your this heading where we discuss two important things. One thing is solubility and solubility of solid in liquid, and on the basis of this equilibrium we discussed earlier, uh, we understood the effect of temperature and pressure on the solubility of, take care of that, solubility of solid in liquid. We're discussing only solubility of solid in liquid. In the next video I will discuss the solubility of gas in liquid, which is actually the Henry law, and very important law. I will explain you in the next video. So I'm going to finish this video.